Okay, here's example 1 for R8, working with tabular data. And the first thing you look at, obviously you read the question. It says Y of T represents the population of a town over a 20-year period where Y is differentiable function of T. And then the table shows the population recorded at selected times. So the first thing you need to know is this is an amount. It is not a rate. Okay, so different tables give you different things. So this is like equation 1. Now that we have that, let's look at what's being asked. Okay, I'm going to go back over here and see this one. Okay, so what's being asked is to find y prime of 12. And they don't tell you what y prime of 12 is. They want you to say what y prime of 12 is. So the derivative of this would be the rate. So that's what you would say. What does y12 mean? It's the rate the population is increasing or decreasing, I would guess. Is increasing or decreasing at year 12. Okay, so that's what you would say for that. Now, let's calculate it. So how do you do y prime of 12 when you're just given data? The only way you can do it is using the average rate of change. Okay, y prime is the rate of change, but we can't take the derivative of data, so we have to use the surrounding numbers, and we usually go the one above it and the one below it. So we would say y prime of 12 is approximately equal to y of 13 minus y of 10 over 13 minus 10. And if it's an FRQ, make sure you write that out. That'll probably give you a point. And then you have to calculate it. That's approximately 3,697 minus 3,108 over 3, which is approximately 538 over 3, or about 196 1/3. Now use your units right. Use exactly the units that they gave you. It would be people per year. Okay, because you're doing it in terms of time. So it would be people per year. Okay, so that's the first example and part 1 of it. Let's go to part 2 of it. Okay, part 2. Use data from the table in a trapezoid approximation with 4 subintervals to approximate the average. Okay, wait, did you see that word average? So that means we have to, it's over a 20-year period. So the first thing we're going to have to do is do it, average population is approximately equal to 1 over 20. Oops, 1 over 20. Times the trapezoid. Now, how do we do the trapezoid? Well, first, you look at the data and you see what they want. They want 4, and so you have 4 subintervals here. Make your little section so you can see it, and then calculate the delta x. What happens between these units? This is 4 years. This is 6 years. This is 3 years, and this is 7 years. So those are the numbers you're going to use. And then they want a trapezoidal. And since these numbers are all different, we can't use any shortcut or anything. So we're just going to add up each trapezoid one at a time. All right, so that would be 1/2 of the first 2 together. So that would be 2,500 plus 2,724. And you multiply that by 4 up here. And that's the first trapezoid. And the second trapezoid would be 2,724 plus 3,108. And that's multiplied by 6. The third trapezoid would be 3,108 plus 3,697 times 3. And the fourth trapezoid would be 3,697 plus 4,283 times 7. Okay? Now, you've got to put that all in the calculator. And this is where a lot of the errors happen. You got to make sure you use parentheses and you don't hit a times instead of a plus or whatever. So you're going to have to probably do this twice. I would do it all in one step the first time if it were me. And then the second time, since I've got nothing to go by, I would do it, add these two together, divide by 2, and multiply by 4 and write the number down. And then do the same thing to this one and write the number down. So you'll get 4 numbers that you add up, and then hopefully you'll get the exact same thing and you'll know you did it right. So be careful with your calculator. All right, so the answer should be, when you add those together and don't divide, it's 66081.5, and then you have to divide by 20 years. So you come out to be approximately 33,304.075. Now your units would be people. That's what the trapezoidal sum gives you, how many people in 20 years, but they want the average, so you have to go per year because you divided it by 20 years. So about 3,304.075 people per year. Go back and look. Does that make sense for what data was given? And you shouldn't come up with some huge number like 20,000. If it's the average, it should be close to some of these numbers right here. Okay, so double check to make sure you did it right. Okay, these are really common on FRQs. Okay, all right, so that was example 1.